Welcome back, everybody. This is day 2 from section 8.5. Everybody playing along at home. I'm going to go through the homework, and then we'll start with the notes. Go ahead and pause where you need to. I've already kind of shown 2, 3, 4, and 5 to my class here. So I'm just going to keep scrolling, but again, pause where you need to. Here is 6, 7. Can we see 8? Can we see 8? Almost. Not yet. Yes, sir. Yes, sir. Anybody else who got it up?
Dude, I'm falling out on this. Right? Oh,
with that English.
And then let me scroll down here. Number 8. Yeah.
That woman here.
Yeah.
What's this?
Yeah.
Here you go.
Thank you. Oh, that's better.
Make sure that you don't say -2 as an answer for number 8. You got to throw out -2 because it's not a solution. It is undefined there. They're showing a lot of work here. Like this one, you multiply in 3 quantity x plus 2. So then it's going to cross cancel here and here, here and here, here and here. That's why you see a -6x, x times x plus 2, which will get us the x squared plus 2x. And then the 12 here. Extraneous. Extraneous.
I'll go have word of the day with CPU.
What's that stand for?
Core processing unit.
Wow. I didn't know that.
Do you know what USB stands for?
USB.
Universal.
Yeah, I was going to say universal storage.
No.
No, what is it?
Standard bus.
Bus?
Yeah.
Wait, universal standard.
I feel like I would have been in computer science if it was offered when I was in high school.
Yeah. I mean, it looks like
Wouldn't that like be roughly the same?
it looks like
Neither answer gets thrown out in number 9, get 0 or 7. And then in number 10, there are no solutions.
Really dumb. I got the x squared minus 7x, and I'm
really
like,
understand that.
what can I do? I'm like, there's nothing to do. Did you not? You didn't. The and close are equally good.
You just stopped there.
Just stop. We were like, oh, there's.
Yeah, just factor out an x. There you go.
Oh, I forgot about
Yes.
So I basically stopped right at the right after the 3 part.
Here?
Yeah.
Okay.
I was really confused.
Well, you just solve it for x. So you just subtract the 3 over to the other side. You get negative x quantity x plus 1 is equal to 0. Then you can divide over the -1, and you get x plus x times x plus 1 is equal to 0. And then so you get x equals 0, x plus 1 equals 0. You get -1.
Why wouldn't you want to change it back to x squared plus x?
You could, but then you have to factor it back, right? So if you're here at x times x plus 1 equals 0, you get x squared plus x equals 0, and then where are you at again? You know, you'd have to get this. So to get a solution, you'd have to factor out the x, and then you said x equals 0 and x plus 1 equals 0. So you end up undoing what you did.
Also, x.
Yeah. Remember that whenever you get it down to something that's quadratic, that's when you have to either factor or complete the square or quadratic formula, whatever, to find the solutions. And most often, extraneous solutions arise when it's a quadratic, when you solve these rational expressions by using some sort of quadratic method. Okay. Question. Okay, let's then get to the notes, shall we? So again, you were given this yesterday. We did the front yesterday, and now we're going to do the back today. I'm gonna make sure my examples match here. So, section 8.5, day 2, we're gonna solve rational inequalities today. We're gonna solve some equations, and but I'm gonna tie it into inequalities as well. Another really stellar definition on the top here. A rational inequality is an inequality that contains a rational expression. Duh. Right? That's like another really stupid definition. One way to solve these rational inequalities is by using a graph and table. Now, you see how in the directions it says use a graph and table? Let's all get out our graphing calculators, and I'm going to show you how we would solve this using our graphing calculators.
Oh, I don't think.
Now, this may not be easier. This may not be more efficient. This may be less efficient. Because honestly, if I were to just solve this algebraically, wouldn't I just multiply the x plus 1 over to the other side and then solve for x? Yeah, but I want to show you graphically how we would arrive at that solution as well. All right. So we go to our calculator and let's plug in. What we're going to do here is plug in 8 over x plus 1 is my y1. So this is going to be my y1, and this is going to be my y2. So let's go in and do that. I go into my y equals, make sure there's no plots on or anything like that. Make sure that it's just blank y1, y2. So we have 8 divided by, start a parenthesis, x plus 1. And then we've got on the other side a -2. Now remember what you should see. Like if before I hit graph, and I know some of you probably already have, before I hit graph, I'm going to try to think about what I should see. First off, the easier function on the right side, y equals -2. Is that just a horizontal line at -2, 2 units below the x-axis? Now, 8 over x plus 1, that is a hyperbola, right? That's got those 2 branches. Where is the vertical asymptote here? Where should it be?
0. No, not 0.
Where should the vertical asymptote be? I'm just looking at y1. -1. Right? Shouldn't there be a vertical asymptote at -1? Should there be a horizontal asymptote? Is it top heavy or bottom heavy? It's bottom heavy, so it's at 0. At y equals 0. So I see a horizontal asymptote at y equals 0. I should see a vertical asymptote at -1. All right, now I'm going to hit graph. Oh, I never turned back on my. Hold on 1 second. Okay. So I see the vertical asymptote at -1. I see horizontal asymptote at my y equals 0. Perfect. This is exactly what I think I should see. And this is exactly what we thought we would see. We have our vertical asymptote at -1. We have our horizontal asymptote on the axis, and then we have here. I'll put this in red. Here is my hyperbola. Yeah, that one will cross the axis. I was getting close to it because it wouldn't cross it, but that one will because it's the asymptote is -1, not 0. And then we have our. I'll put this one in blue here. -2. Now, if I just want to know when these are equal, where am I really looking for? What am I really looking for? The intersection point. So let's find that real quick. Second, calculate intersection point is choice 5. Now, it's going to ask me first curve, second curve, yes. Now, normally we would just keep hitting enter. Boop, 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 right away. But if I do that in this case, enter, 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 it's never going to find it. And here's the reason why. Let me go back and do that again. Everybody watch my screen here. Where is my cursor? On the right branch of the hyperbola. So again, your calculator is a very dumb, smart object. All it's going to do is run values where I put my cursor. And it's going to run values where I put my cursor on the other graph. And then it's going to see where they match. But it's just going to do it really fast. Now, it's going to run values on that line. but it's never going to find, because it's going to stop at my asymptote, it's never going to start running values on this other curve. So what I have to do is I just have to arrow over until I see it jump over to my other branch. There it is. You see my cursor now? It's on the other branch. It's where the intersection point actually is. Now if I hit enter, and then I hit enter, and then I hit enter, now it's going to find it. Okay? So my intersection point is at -5, -2, the x value being -5. Questions about that? Now, that's solving for an equality. What if it's an inequality? What if it is x over x minus 6 less than or equal to 3? Well, it just needs some more interpretation. It's not necessarily more difficult to find, it just needs some more interpretation. So we're going to do the exact same thing. We're going to say this is my y1, and this is going to be my y2. I don't know what those little brace things are. But again, before you hit enter, before you graph it, visualize what should happen. Let's talk about my right side, my y2. Isn't that just a horizontal line at 3? Okay, so I should see a horizontal line at 3. And on the other side of my inequality, I see x over x minus 6. Well, let's kind of analyze. Where's my vertical asymptote going to be? Where's my vertical asymptote of that rational function on the left side? 6. Right? That's where it's undefined. It's 6 at x equals 6. Is there a horizontal asymptote? Yes. Is this top heavy or bottom heavy? It's neither, right? They're the same numerator to denominator. So the rule is we take the leading coefficients and we divide them. So 1 over 1, I know my horizontal asymptote is going to be at y equals 1. So I know I'm going to have a horizontal asymptote at y equals 1, a vertical asymptote at x equals 6, and beyond that, I really don't know what else it's going to look like. So let's go ahead in my graph now and do this. I've got x divided by quantity x minus 6 divided by, and then the other y2 is just 3. I'm going to graph. Okay, so let's see what I have here. Now, am I looking for just the intersection point right now? No, because I do care about where they cross. But that's not just my answer. I care about where they cross, but that's not just my answer. Let me take a look at and find where they cross. Let's calculate the intersection point real quick, because that is going to be a key part here. I have to scroll my cursor all the way till I get on that other branch. There it is. And I see my intersection point at 9. At 9, 3. I'm just going to replace this one here. I see it at 9, 3 over there. Now we got to analyze what we want. Right? We got to analyze what we want. We want the rational function based on the given problem. We want the rational function to be underneath 3. So like here, my blue line I'm kind of exaggerating where it crosses there. My blue line to be underneath my red line, right? I want my blue line to be, because when we compare x to x minus 6 over, or sorry, x over x minus 6 to 3, I'm looking for vertically, above and below. Less than means below, greater than means above, right? Not talking about left or right, I'm talking about up and down. So where is the blue line underneath? Where is the blue function underneath the red function? Where is it underneath the red function? Well, I guess maybe a better question is where is the blue function on top of the red function? Isn't there only one spot? Don't you see here? This is the only piece where the blue line goes above the red line. So if I'm looking for When is it below? Well, let me highlight the places that it's below. Isn't it below all down here? Isn't it below starting at this value all the way forever and ever? So that's my solution. That's how I have to figure out where my solution is. All right, so let's write it out. What is this defined with my x values? Well, where is this vertical asymptote again? Where was that at? 6. So any x value below 6 is the solution. Can I include 6 as an x value? No, why not? The asymptote, it doesn't compute. It's not equal to 6. I can't be equal to 6 or else my function would be undefined. All right, so x is less than 6, and now I take the other piece. Anything above what? 9, the x value. Anything above 9, x is greater than 9. Should I put the or equal to on that one? Yes. You never put the or equal to on the asymptote. But the other one depends on whether it's going to be what's in the original function. So there it is. X is less than 6 or x is greater than or equal to 9. That's my answer. Again, in my opinion, it would be easier to solve this algebraically rather than trying to use my calculator, in my opinion. Because sometimes it might be hard to logically reason through where my solutions are going to be. So how would we solve it algebraically? Let's take a look at one to solve algebraically here. It says example 3, but it's actually example 4 in the paper, sorry. Solve 6 over x minus 8 less than or equal to 3. And I'm going to solve this algebraically. Now, this is going to require us to use a method that we used before when we talked about quadratics. Okay? Remember doing that thing where we created a number line? We found critical points and tested values in between and created like a yes, no, yes, or a no, yes, no. Remember doing that? This is going to be very similar to that. So what I'm going to do, first thing, is find my critical points. Find my critical points. Those critical points are going to go on a number line, and then we're going to pick out tested values and run them through my original function. So here's what I mean. I've got to find my critical points. Now my critical points are any intersections or any asymptotes. Asymptotes. I always forget the P in asymptotes. All right, so let's find the intersection first. Let's find the equality. 6 over x minus 8 is equal to 3. All right, like I said, it's pretty easy algebraically to solve this. So multiply the x minus 8 over. 6 is equal to 3 quantity x minus 8. And heck, why not? Just divide by 3 before I distribute. 2 is equal to x minus 8. So 10 is x. So my first critical point is 10. Okay, x equals 10. Where is my other critical point? 8. And x equals 8, because that's my asymptote. And I should have been a little bit more specific. I should have said I only need the vertical asymptotes. I really don't care about the horizontal asymptotes. I said asymptotes, and I really should have just meant vertical asymptotes. So x equals 8 is my other critical point. And I get that from the denominator of my rational. Now, I go to my number line, and I say, okay, I've got 10 and 8. So I'll put it here, 8 and 10. And now we're going to pick out some tested values. These you can choose. Let's pick an easy point to the left of 8. 0. We can pick 7. essentially, isn't 7 going to tell us the exact same as 0? Right? No. 9, and then we'll pick 11 on the other side. All right, so let's run this through. Let's see. I'm going to get, if I plug in 0, I'm going to get 6 over negative 8, right? So negative 6 over 8. I don't even need to reduce that. Is that less than or equal to 3? Is a negative number less than or equal to 3? Yeah. So this is a yes. There are solutions to the left of 8. Now, you know how I said it was either a yes, no, yes, or a no, yes, no for quadratics? That's not the case anymore. Okay, that gets thrown out the window a little bit because, again, this is not quadratics. So we have to be a little bit more careful now. Just because we see a yes doesn't necessarily mean that it's going to be a no yes. It could coincidentally happen, and I think it might actually do that. Well, I could actually run the number here. 6 over 9 minus 8. 6 over 9 minus 8 is 1, so 6 over 1 is 6. So 6 less than or equal to 3. Is that true? No, that is not true. And then I say 11. 6 over 11 minus 8. Well, 6 over 11 minus 8 is 3. 6 over 3 is 2. Is that a true statement? Yes. So this one does coincidentally come out to be a yes, no, yes. All right, so let's kind of draw it out on our number line. Let's draw it out on our number line. I know there are solutions to the left of 8. Should I put an open circle or a closed circle on 8? Open. Can I be equal to 8? No. So I'm going to put an open circle on 8 pointing to the left. Nothing in between here. Should I put an open or closed circle on 10? That one's closed because my original sign was 4 equal 2. All right, so that means, let's write this out as a statement, as an inequality statement. So this is pointing out, this is going to be an or. X is less than 8 or X is greater than or equal to 10. Okay. Go with your critical points, not your tested values. A very common mistake when we were doing this before was saying, oh, X is less than 0 or X is greater than or equal to 11. No, we chose 0 and 11. We didn't choose 8 and 10. Those were within the problem. Okay, let's do another one of these. 4 over X minus 3 is greater than or equal to 2. So again, we're going to solve this algebraically. We got to find our critical points first off. And our critical points are where the intersections happen and where the asymptote, vertical asymptote is. So 4 over X minus 3 is equal to 2. So I multiply the X minus 3 over to the other side. I can divide by 2 here and add the 3. X is 5. I could have distributed the 2. 2x minus 6 and then add the 6 divided by 2. I'd get 5 as well. Where's my vertical asymptote? X equals 3. Go to my number line. I see 3 and 5 are my critical points, and let's pick some tested values. Let's go 0. Let's go 0, 4, and 6. So if I plug in, sorry, were you hoping for something different? Sorry. 4 divided by 0 minus 3, so 4 over negative 3. Negative number. Is a negative number bigger than 2? No. And then we have 4 over 4 minus 3, so 4 over 1 is 4. Is that greater than or equal to 2? Yep. And then we plug in 6. 4 over 6 minus 3. 6 minus 3 is 3. I'm going to get a positive 4/3 in this case. Is that greater than or equal to 2? 1 1/3? No. So this one actually does turn out to be a no, yes, no. They don't always do that. It could be like no, yes, 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 no, whatever. But in this case, I see there are only solutions in between 3 and 5. Can I be equal to 3? No. Can I be equal to 5? Yeah. So here are my solutions. So that's an and because it's pointing in right there, right? So it's only in between 5 and 3. Questions about that?
I defined it.
Because these were no's. So I know that there are no solutions on the left side of 3 or the right side of 5. The only solutions are in between 3. Questions about that? Feel good about that? All right, so that's section 8.5. Tomorrow in class, we'll be doing a game, fun game.
Mario?
It's a math game.
Baseball.
Say bye to everybody.
Bye.